Page 561, lesson 9.3 is on solving quadratic equations. So solving equations, what we're going to be doing basically is we're going to be looking at essentially where the graph intersects the x-axis, where our x-intercepts are, is what it's going to boil down to. Quadratic equation, once again, we talked about previously, quadratic equation. This is an equation, sorry. We talked about a quadratic function. This is a quadratic equation. So quadratic equation can be written in this form. Okay, so before we had y equals ax squared plus bx plus c. Here we have ax squared plus bx plus c equals 0. Okay, and that's called the standard form of a quadratic equation. So we can solve quadratic equations different ways. One way is we could graph this and we could find the x-intercepts. So just for example, previously we had something like y equals 3x squared plus 5x plus 2. So in this section, we're going to take an equation like that and we're going to say 0 equals 3x squared plus 5x plus 2. We're seeing where y equals 0. Where y equals 0, that's going to be on the x-axis. Okay? Any point on the x-axis, y is equal to 0. So that would be one way to do this, is to try to graph this. Try and graph the equation and just look for the intercepts. Look where it intersects the x-axis. There's other ways we can actually work this out by hand. So what's going to happen when we do these problems, we could possibly have 2, 1, or no solutions. So before we look at those options, I guess we'll mention this has 2 solutions. There are 2 points where this hits the x-axis, so this has 2 solutions, okay? And sometimes they're going to call these real number solutions, okay? So kind of like the example in your book there, this has 2 real solutions. And this might seem strange that I'm saying they're real solutions. At this point, you might think I'm making this up, but there are actually things you'll learn about in high school called imaginary numbers. It's a thing, okay? So these are 2 real solutions. This could be where our vertex hits right on the x-axis. That would have 1 real solution. It just has 1 x-intercept. Or it's possible that our graph actually never intersects the x-axis, in which case we have no real solutions. Okay, so these are the 3 different possibilities that we will be facing when we try to find our solutions to quadratic equations. So if we go back and look in your book here again, the bottom of the page talks about some different things that are synonyms here. We can use these interchangeably. Solutions, x-intercepts, roots, and zeros of a function. All 4 of those can be used interchangeably, okay? So if they say what's the solution, or what's the x-intercept, or what's the root, or what's the zero, those basically all mean the same thing for these problems. So if you look at problem 1, they're asking what are the solutions of each of these equations. Use a graph of the related function. So for part A, they're wanting us to find the solutions of this x squared minus 1 equals 0. So what they're doing is they're graphing y equals x squared minus 1. And then basically it's just we're looking at, for our equation, we had a 0. We replaced it with a y. We're wanting to see where y equals 0. In other words, we're wanting to find our x-intercepts. So they graphed this. So we'd have to do like we did in the previous lessons, find the vertex, or find the line of symmetry, find the vertex, find some points on the graph, and then hope that these x-intercepts come out nicely. Okay, in this case they do. You can see this intersects at -1, where x equals -1, and this intersects where x equals 1. So -1 and 1 are the two solutions. Now what that means is, going back to our equation, that means if you put a -1 in place of x and you work this out, this would be equal to 0. Okay? -1 squared, -1 times -1 is 1. 1 minus 1 is 0. So that works. Also, if we put a 1 in, 1 minus 1 is 0. So that works. Okay, and that's where the book is just abbreviating this a little bit. Sometimes if the numbers are identical, one's positive, one's negative, you can write it that way. Plus or minus 1, it means 1 or -1. Okay. Part B, similar idea. X squared equals 0. So we're graphing y equals x squared. And when you graph this, there's only one solution. The vertex hits on the x-axis, so that's our one solution, which is 0. And then finally, if you look at part C, if we graph this equation, that +1, remember, is going to shift our graph up 1 unit. And so actually, we do not have any real number solutions for that one. It does not intersect the x-axis at all, so no real solutions. So if we look at the got it, they're wanting us to find the solutions of the equation, use a graph of the related function. Okay, so in the next problem, we'll actually be looking at working these out by hand, which is going to be a lot quicker method, we'll find, I think. But we'll go ahead and go through the process, then maybe you can appreciate it all the more. So part A, we've got x squared minus 16 equals 0. So we're going to put a y in place of that, and usually they just switch it around and say y equals, instead of x squared minus 16 equals y. They just start with the y. And one thing you could do, we could just think about what values of x would make it equal to 0, and I think we could probably be pretty successful with that. But it did talk about doing a graph, so we'll go ahead and go through the process of the graph here. So line of symmetry, we would be looking at finding that first. Line of symmetry, x equals -b over 2a. And remember, that's based off of y equals ax squared plus bx plus c. This does not have a middle term. It doesn't have an x term, so our b is really 0, which we've talked about before. Technically, if you don't have an x term, then your line of symmetry is just going to be on the y-axis. It's going to be x equals 0. Okay. A is equal to 1. We have a 1 in front of the x squared there, but it doesn't really matter because we've got -0 over 2, or 0 over 2 would be equal to 0. So our line of symmetry is x equals 0. And then next we could find our vertex. In this case, you might remember we talked about what that number does. So comparing this to like y equals x squared, we have this -16 at the end, which is shifting our equation, shifting our graph. So the -16 is just shifting our graph down 16 units. So instead of at 0, 0, we're at 0, -16. Or if you forget that, it's not a big deal. We just substitute a 0. Put a 0 in place of x. and you would get negative 16. So 0, negative 16 would be our vertex. Okay, and then from there we want to find some other points. And what we need to remember when we're doing this is our goal ultimately is to figure out what the x-intercepts are. So what I'd like to do when we're working this out is put a number, at least for a couple of our numbers, where we put in an x and we get a 0 for y. So you guys might be able to imagine that without actually just randomly guessing numbers if you want. So what we can do, if you want to think about this, you know, we've got y equals x squared minus 16. If we want that to equal 0, something squared minus 16. So you think about if you did 4 squared equals 16, okay? So that would be 16 minus 16, which is 0. That's exactly what we want. So 4, 0 would be 1 point on this line. And then remember, our line of symmetry is on the y-axis. So we just sketch this out here, I guess. Okay, so we've got 4, 0. Our line of symmetry is this y-axis, x equals 0. Okay. So we can think of that. We can think of the reflection point from that. So this point, 4, 0, is 4 units away from the x-axis from our line of symmetry. So we need to go 4 units away on the other side of that, and that would be negative 4, 0. Okay. We could find some points in between here. You know, normally we'll get 5 points. So I mean, we could try 1. That'd be 1 squared is 1. Minus 16, that'd be negative 15. So 1, negative 15, and then also negative 1. Negative 15 would be its reflection point. Okay? But ultimately, really our goal here is just finding those solutions, finding those roots. And so really, the main thing we're after here is these intercepts. So we could say that negative 4 and 4 would be our solutions for this equation. So look at part B. Clear out some of these things here so we got some room maybe. Okay, so we're thinking about on this one, we got 3x squared plus 6 equals 0. So we're thinking about y equals 3x squared plus 6 if we were going to graph this. We don't have a b term, so our vertex, our line of symmetry is going to be x equals 0. And then our vertex, if you can think about, remember we talked about how this value of c can shift our graph. So y equals x squared, our vertex is at 0, 0. So for this, the vertex would be at 0, 6, because that's shifting our graph up 6 units. So if our vertex is at 0, 6, another thing to think about is what direction this graph is opening. So since this is a 3x squared, since that's a positive a value, then this graph's going to go opening. It's going to be opening up. So our vertex is at 0, 6. It's opening up. And so its graph is going to be looking like this. Remember, our goal here is finding the solutions, the roots, the x-intercepts ultimately. So this actually does not have any x-intercepts. Here's our x-axis way down here. Okay, we were at 0, 6, remember, for our vertex, and it was opening up. So this is going to have no real solutions. Okay, so you could say what are the solutions? I guess we could say no solution, maybe say no real solution. And if you think about this, whoops, I'm looking over here, sorry. For B, this is no real solution. Okay, if you think about with this equation, this might make sense if you think about it a little bit, because what happens is we have, with our variable, we have x squared. So if you take something times itself, positive times positive is positive. Then if we took that times 3, that would be positive. Plus 6 would definitely be positive. If x was negative, same idea. Negative squared, negative times negative is positive, times 3 is positive, plus 6 is positive. There's no way we can get this to equal 0, okay? Because we're just going to end up with a positive number no matter what we do. You might say, well, what if x was 0? Yeah, well, that's our vertex, basically. You got 0 squared is 0, times 3 is 0, but then plus 6 is 6. So, again, no way we can get this to equal out to 0. If we look at part C, this one's a little bit different. One thing is different here. So different here is that this is equal to negative 25 instead of equal to 0. So we're going to do something about that to start out with. We want it to be equal 0 when we start this. And those cancel and those cancel. So basically we've got x squared equals 0. And then really we're just thinking about what values of x could we substitute in that's going to make this work, which you might already have in your mind. From a graphing perspective, we could think of the graph y equals x squared. Y equals x squared, that's just our basic graph. We've got x equals 0 as our line of symmetry. We've got 0, 0 as our vertex. And then this is going to open up. So this graph will just be looking something like this. And so if we're thinking about our solutions or roots or x-intercepts, so this would have one real solution, which is at the vertex. Okay, one real solution, which is 0. Okay, it says what are the solutions, so I guess we'd say 0 is our solution, and it is our only real solution. This is the case where the vertex is right on the x-axis. So this gives you a little bit of an idea on solving quadratic equations, at least from a graphing standpoint. We'll look in the next video on how to do this, working these out by hand. Have a good day.